non-factual answers, and one of a very promising method to reduce these non-factual answers or hallucinations as they're called is by using RAG. This is not the only way to do so, but one of the most prominent way to do so. So what is RAG? In generative AI, the era of Gen AI, integrating integrating search is very important to ground LLMs with factual context. And RAG essentially lets you do that. How exactly does RAG let you do that? So RAG lets large language models access external data. And because RAG lets LLMs access external data, it enables creating a domain-specific dictionary for your large language model application. And as you can imagine, because you can customize your retrieval augmented generation or RAG-based pipeline for multiple different domains, you can essentially create a very domain-specific application using LLM. Imagine your company has some proprietary data set that nobody else has access to, that the LLM was never trained on. How is the LLM supposed to know how to generate responses based off of that proprietary data? That's where RAG comes in. So if you are, let's say, a tax processing company like Intuit or TurboTax, and you want an AI chatbot that is specifically associated with some customer's specific tax return, that is where RAG could be useful. If you have to design a recommendation system for some internal company pipeline and internal company demo, then that's another way or use case where RAG comes into play. Why? Because RAG enables LLM to maintain up-to-date information. And how can you do that? We can essentially change the document source where the external document source where the RAG is querying the information for dynamically. We can update the documents, delete the documents. We can tell the RAG system that these things have become outdated, don't focus on them, and so on. And that is why, because of all of these dynamic knowledge changes, more groundedness in the source of truth, you get enhanced accuracy. You can evaluate the responses of a RAG-based system because you already know you have the ground truth information. If your LLM produces a response, you have, let's say, 100 documents from which the LLM should have produced a response, and you can evaluate the accuracy of your system like so. You can update your knowledge or the source of those documents. You can create these updated set of documents, and there can be a batch process that reviews all the documents in the vector store that the RAG is querying from on a weekly basis or a daily basis so that your knowledge is maintained. And finally, it mimics domain expertise, right? An LLM need not be an expert in tax or financial statements, but because I have given it access to all sorts of tax information or financial information specific to a particular company, now this LLM-based system mimics a domain expert, and that's where RAG also excels. So before diving deep, let's understand a fairly simple concept that makes RAG-based systems work. So typically, the way RAG-based systems work is that a user asks a question. That question is then in a normal LLM. Let me see if I can actually go here. Right. So in a RAG-based system, what typically happens is that you have an LLM, or I'm sorry, in a non-RAG based system, you have an LLM. Some input comes in, like what is the weather in Delhi? And that gives you an output. Now, this is something which is happening in a normal LLM. And a very reasonable response could be the weather in Delhi is 28 degrees Celsius and foggy or whatever. That has nothing to do with the fact that right now the weather in Delhi is 28 because this system has learned that a question like this, uh, what what if question with the word weather in it and then the name of a city, a very reasonable output is to create these set of words, which is the weather in this city is something something followed by a degree C symbol. This is what a normal LLM would do. On the other hand, what a RAG-based system would do, for example, is let's say if it has an input, it will first take your input and then look at uh, some database. So it will pass your input through the database and check if there's something in that database which matches your input very closely. If there is, it's going to retrieve those documents back up into your input, and then that combined input is the one. So like input plus docs is the one that is passed to the LLM, and then that gives you an output. So that's a very 10,000 feet view of your RAG-based system. Let me again go back to my presentation. Right. So that's the idea behind RAG. We essentially explained this thing on that slide, or on that handwritten note that I was drawing. And what that does is that because of this external database and tooling that we have set up, it enables you to do multi-shot prompting associated with RAG. You can also enhance this LLM with multiple different tools and integrations. Like I was giving an example of weather API is something that you can use, and weather API combined with an LLM call is called a tool, for example. In this way, you can provide additional context to RAG-based systems. They have additional context because one, they have access to external tools. You can still do your multi-shot prompting as you would have in a normal LLM as well. And because of the combinations of these first 2 points, you can mimic additional context for these systems. And later on in the demo, we'll work with the toy example where we have a company. Let's say that company has insurance related products. They have certain contracts, they have certain employees and the employee records, and also certain products associated with their insurance products. And we'll see how we can create a knowledge structure based on all of these different pieces of information and design a LLM based system to answer questions around this specific company. So typically a RAG pipeline begins by prepping up the LLM. So we prep the LLM or we prime the LLM by giving it a very broad level context of where it's operating or what space it's operating in. So typically you would have like a system level prompt that is something like you are an expert in answering questions about insurance LM. This is like a tech company that specializes in insurance. Give accurate answers. If you cannot find the answers in your database or in your documents, just say I don't know. Don't make anything up. So you can create prompts like this, which essentially, no matter what question the user asks, if first prompt is going to be a large high level information like this. And what this does is that this is known as instruct. This is somewhat similar to instruction tuning. What this is doing is that it's telling the LLM to adjust its internal parameters or the weights towards a certain type of a response. And this instruction tuning is important for mitigating what I was alluding to previously, these non-factual responses or hallucinations. So we talked a lot about this RAG pipeline. One thing that I was mentioning is this store, right? We have this database where you go and query for your document. So let's try to see how you can create this database. What are some of the open source packages that enable you to create these databases? So one important thing when you create a RAG-based system is designing a vector database. Why do you need a vector database? Why does something like Postgres, SQL, or some of the other relational or non-relational databases won't work? The reason why they don't is because they are known for, or they are very good at storing structured data. What we want to store in a RAG-based system is, in a way, unstructured data, right? We want to store pieces of text, pieces of documents, and not just the entire document. Maybe we want to store paragraph by paragraph associated with each document. And then we want to make a claim that this paragraph relates to the entire document, so and so. We also want to store the context associated with that paragraph and have some information around that stored as well. And how can you really store this information? You cannot dump all of that document into a database because the computational cost and the memory footprint associated with that is infeasible. So you need to design it in a clever way such that you are capturing most of the information and yet not exploding your memory usage. So that's where vector embeddings come in. What vector embeddings are essentially is that they are vector embedding is a process where you take your text-based information or image-based information and convert the text-based embedding into a numerical representation. A quick check, guys. Can you hear me okay? I
So as we
saw
can
some
hear
comments.
you loud and clear, I think this is some specific use case where somebody said they can't
Okay,
hear
that's
you.
fine.
And
Cool,
please do
thanks.
check your system, maybe increase the volume, but thank you so much.
Great. So that's vector embeddings for you. Vector embeddings, a one-line explanation is taking text, video, audio, image information and converting them to a set of numbers. So, or a vector of numbers. That's what vector embeddings are. And they enable AI systems like RAG-based architectures to search semantically relevant information from your vector databases. What does semantically, what does semantic meaning mean? We'll take a look at that a little bit later. So vector embeddings, again, as I mentioned, convert your text into numbers that represent the meaning associated with that text. For example, OpenAI embedding will have each each word or text is converted into 1536 dimensional vector, and the input types can be many, right? The input types can be some characters, words, paragraphs, sentences, abstract concepts, and so on. And this is what semantic meaning means. Semantic meaning means, if I ask you a question, uh, if the word king is close to a man, what is the word woman close to? The answer should be queen, right? And this is the type of question answering that vector embeddings enable you to do. What happens is that because you have transformed your text-based information into a numerical representation, you can create vectors and do mathematical operations on those vectors. It's very difficult for me to answer questions like, what is the distance between mountain and hill? Like, what is the distance between the words mountain and hill? What is the distance between the words Delhi and India and Washington, D.C. and USA? What's the distance between France and Paris? So it's it's because this is text-based information, we need a method to convert this text into a vector representation. And then once you have vector, you can answer these questions of uh, what is close to what. Why can you do that? You can do that because typically, um, what you can what you typically see is if you have a vector like this, king, and another vector like this, man, when people say that the two vectors are close to each other, what they are doing is they are calculating this angle and taking the cosine of that angle. So as we have all learned, cosine of if the two vectors are very similar, that means the angle between them is zero. So cosine of zero is one. And if the two vectors are very far apart, like let's say this vector here is, I don't know, mountain, and the angle here is 90, and so cosine of 90 is zero. So all that means is that mountain and king are very different. King and man are close. So that's how vectors and then the similarity between vectors work. Right. So we have seen that the entire picture of RAG-based system therefore looks like this. We convert our input prompt, which is text-based information, into this numerical vector embedding. Once we have the vector embedding, our vector database also has a series of vectors like this associated with our proprietary documents. Now, because we have a series of vectors and our input embedding or our input prompt comes and we have also converted that to a vector embedding, now we can do this cosine similarity search type of an operation in our vector database to find most relevant documents associated with our input. And once we have that, we can augment our prompt or append all of those documents and the context associated with those documents to our prompt. And that augments our input to the LLM system so that it gets more context. That's why the name, you retrieve the documents and then you augment the prompt. That's why the retrieval augmented generation. And that combined input is passed to the LLM to then generate a response. So we'll see in the demo later on that there are many tools out there like LangChain, LangGraph, Crew AI, um, uh, N8N is another one, which is a no-code framework. We'll look at LangChain, but LangChain allows one of the code frameworks is LangChain. It allows you to build these RAG-based systems and other AI apps very fast. It has access to multiple databases and APIs and vector stores that you can easily integrate into. It supports memory, so you can make your LLM system remember short-term and sometimes long-term conversations. And it also has integrations with various other providers of these systems. So some of the advantages of using packages like LangChain are that you can build a strong proof of concept relatively quickly. It has standardized workflows for not just RAG-based applications, but a variety of other LLM-based applications. Um, it has model agnostic wrappers. So if you want to use GPT 4.0, or if you want to use Claude, or if you want to use some other company's LLM, you can switch them back and forth fairly easily with just a few lines of code. Um, and some of the considerations there that you may want to think about are that the APIs associated with certain methods in LangChain have matured since the last 2, 3 years. They therefore keep changing their function calls, and so you still have it still provides you a very strong head start, but you need to be careful on keeping up with what they have changed on the back end from their end. So another thing that another thing that LangChain provides you with is something known as document loader. What that does for you is that it takes a series of documents that you can parse through. They could be text files, PDF files, CSV files, some other unstructured data, and it transforms all of that data into queryable chunks. So we'll take a brief look at what chunks are, but chunks are nothing but just if you have a 100-page document, a chunk could be one-fourth of a page, and you essentially have 400 such chunks for a 100-page document, for example. And all of that is done for you internally through directory loader object from LangChain, and you can create document objects which are then ready for processing into a vector database. So we talked about chunking a little bit. Chunking is essentially a method to break your document into different pieces, and those different pieces are then converted into those vector embeddings that we talked about earlier. And there are many different strategies associated with chunking also. For example, there are certain documents which have an inherent structure to them. For example, code files, right? Code files have, maybe you have like a main.py, and then that main.py calls f1.py, f2.py, f3.py, and it makes sense to therefore chunk those documents on a file by file basis. On the other hand, there are some other documents like legal briefs. Legal briefs also have a certain structure to them, and maybe you want to chunk them by section as opposed to a file by file or page by page. On the other hand, there's stories. Stories have a certain flow to them. There's a certain continuity, and for storybooks, maybe you want to chunk them page by page and also have like a chunk overlap so that the flow of that story is maintained. So there's a variety of different chunking strategies that you can also deploy, and those are also enabled to you with packages like LangChain and LangGraph. So once we have our documents, once we have broken down those documents into a variety of different chunks, chunks meaning just different, like broken down a large piece of text into smaller pieces of texts. Now the time has come to convert those small pieces of text into embeddings. And we have a variety of different embedding models also. So there's transformer architecture based embedding models like BERT, Roberta, and so on. There's before the transformer architecture, there were models like Word2Vec. Word2Vec was a, as the model name suggests, it converts words into vectors. Those were some of the models that were before the era of transformers. But today we have open source models that essentially convert your piece of text into vector embeddings. And why do we need vector embeddings again? We need them so that we can query our text for achieving this semantic meaning between two different pieces of text. So that's a little bit about vector embeddings. The next thing that I want to talk about, so let's take a step back and quickly look at our uh, look at our RAG-based pipeline at a very high level. One thing that we have is our input, which is just a simple prompt that goes into your LLM, which can be any LLM. It can be a closed source model like Claude 4.0, GPT 4.0, and so on, or it could be an open source LLM like Llama that you have on your local machine. That doesn't matter. Um, Something that we haven't talked about is this vector DB. Um, Vector DB stores all of your documents. All of these documents are stored in your vector DB as this vector representation. And the way they are stored in the vector DB is also by a document is not stored completely in a vector DB. Maybe this document is broken down into multiple different chunks. And all of those chunks are then stored. Same thing with this document. It's broken down into some more chunks. And all of those chunks are stored in your vector database. Now what will happen is your input goes to the LLM. LLM first checks into the vector DB on how closely matched is your input with some of these documents, and it retrieves those documents back and appends them to the input prompt. And now this produces an output. So we saw at a very high level what your documents look like, what your chunking strategy look like, what your LLMs and outputs and inputs look like. Now I want to talk about just this red cylindrical thing here, which is your vector database and some of the options available to us for vector DB. So there are many closed source and open source packages to create and manage your vector databases. Some of the common ones that I have used are very reasonable ones and robust are ChromaDB, which I'll quickly show today. Some other ones that I've also used, which are very good, are Pinecone. Pinecone DB is another vector database. Qdrant is another one that is very popular. But all of them essentially do the same thing. They take a bunch of documents, convert them into vector embeddings, and store them efficiently for fast retrieval. And all of them offer straightforward APIs to manage complex querying tasks. So most of them have also good documentation associated with this. So Chroma, for example, there's a fairly high level all the abstraction is taken care of from you. So all of the methods on top of the Chroma object that they have designed for you are fairly self-explanatory. And so and all of these vector DBs are easily integrable into LangChain architecture as well. And so what it enables you to do is something like the following, right? So as I was mentioning, this whole man, king, woman, queen type of examples, what it enables you to do is cluster your text into similar groups. So for example, here, the graph on the right shows if you take some documents and convert them into vector representation with each vector having this high dimensional space, you can plot them on a two-dimensional or a three-dimensional space such that all the similar dots here correspond to documents which are or all the verbs in the document. All of the green dots are the adjectives. All of the so you get the point. All of the points in the same cluster essentially combine a meaning which is something similar. All of these white dots are nouns, for example, and so on. And so because you can do this clustering, you can visualize the meaning behind some of your texts and the documents and the dimensionality associated with those documents. For example, you can identify, okay, which cluster of documents belong to company specific things, which cluster of documents belongs to the contracts associated with our products, which documents describe the products associated with the company, what documents are employee records and some personal records. You can create or ask questions like these based off of your vector database and the clustering and the embedding that you did. And so, right, this is another one which I forgot to mention. FAIS, which is Facebook AI Similarity Search, offers in-memory vector storage. It's also another vector DB, which is an option as opposed to Chroma. It has CPU and GPU variants, very drop-in replacement. These are just some options which do basically the same thing, but one optimized for very slightly different things. And right, as I said, LangChain has given us APIs and methods which are fairly abstract. So if you have a vector database, your method that you're calling on the vector database object doesn't change. For example, if you decide tomorrow that you want to use Pinecone and not Chroma or FAISS, then the from documents method is going to be available to you in both, as long as your object here is a vector database. And that's essentially the beauty of LangChain's abstraction. So that's what I wanted to cover. Rohan, do you want to take? Um,
Sure, folks. Firstly, Surya, thank you so much for taking this up. Folks, we have like a demo lined up, which will be the more extensive part of the session. I think demo will take around 30 minutes, right, Surya, if I'm not wrong, the whole demo coverage.
yeah, maybe 15 to 20 minutes.
Got it.
Because I won't because the demo takes because the notebook takes time to run. I'll just not run it live, but I'll just show how to do it.
Yeah. Surya, there are a lot of questions. How about we take a few questions right now so that people,
Sure.
like even live for that matter, how would you want to start? Would you want to take some from the Q&A section or from the chat? Because there are pieces that come from both the sides.
Right. So I can do the Q&A and then answer those step by step if that's okay.
Sure, that works. Let's pick like two, three from the Q&A section as of now. And then if you could address some via text while Niyati covers some content, and then we can get into the demo part.
Okay. So Divya has a question. What is an LLM? That's a good question. LLM stands for large language models as opposed to small language models. So what are small language models? Small language models are something like a few years ago, you had models like n-gram models, which were just statistical models, or frequency-based models, which would just consider frequency of certain words occurring in your text and then produce responses associated with how common a particular sentence or a word is in your document and then make predictions based off of that. LLM, on the other hand, is very different. It's a non-statistical model, right? It's a machine learning, deep learning based neural network architecture that is trained on billions and trillions, trillions of parameters and thousands and millions of different documents. And that's why the word um, it's a language model because it predicts the next word given some previous words. That's why it's a language model. It's large because it has billions and trillions of parameters. So that's why it's LLM. Hopefully that answers the question. Um, I think, let me see, how to customize.
I think Surya, I have an alternate idea. I'm sorry, folks, if I'm confusing you, and you, Surya, as well. There are a lot of questions that going to keep coming in. How about we close the demo also? Like once Niyati closes her part, then we close the demo, and in the end, we keep like dedicated 30-minute, 25 minutes for folks to address their questions, because there are a lot of questions which are coming both in chat in the Q&A. By that time, what
Yeah,
I'll do is I'll try to pick some questions in a doc format so it's easier for you to address. And folks, there'll be no cherry picking. It's just like I'll be randomly going through in a structured manner, seeing what makes more sense to
sure.
address. That will be better. Uh,
Yeah,
so you can stop sharing your screen, Surid. Um, Folks, by the way, we have with us Niyati as well. Niyati is a part of our curriculum team. She leads the curriculum team specifically for India. She'll be quickly walking through how the market is shaping up and also very briefly touch upon Interview Kickstart's offering as well, so that any of you who is interested to know about us can get to know additional flavor about us. You know about our instructors or you know about our pedigree. Niyati, over to you. Once you're done, then we'll get to the demo. And in the meantime, Surid, I'll be like copy pasting the
yeah.
questions, particular structure. So it's easy for us to pick those up.
Sure. Okay. Uh, just give me a second. I hope my slides are visible on slideshow
Yeah,
and
and
audible.
you can hear you, see you, and your slide is visible.
Awesome. Great. I think by the amount of questions that Surhit has to answer, I can totally understand how engaging this session is already. And I think there's a bunch of stuff to look forward to. So hang on, guys. I'll not take too much time. So I'm Niyati. As Rohan mentioned, I work with the curriculum team here at IK India. And I've been working in the education and upskilling space for over 5 years now. So right about when AI was, gaining popularity to the time when now it is at the center stage. So I've had the opportunity and fortunate opportunity to actually talk with a lot of technical professionals like yourself and understand how do they observe AI some of you, like in our survey also, in the poll, starting some of you and at work, right? So and looking at the interest that you guys are showing, what I can understand is I can easily segue into the next few slides that I have for you. Okay, so what firstly I'm gonna take you through what we do at IK, what do we have for you, and how can you take this interest in just AI or RAG to the next level and actually start using it at work and start using it to see that multifold effect on your career. So at IK, we have two offerings at this point of time. We have the interview preparation track, and we also have the AI upleveling track, right? Now, so interview preparation is something, as Rohan was taking us through the history of IK, we are an 11-year plus old company, started in the Silicon Valley. Interview preparation was something that we started with and quickly segued into also up-leveling technical professionals with AI skills, right? And what's the need for it is the number one question that we get asked, right? Like some may feel that no, it's just starting off, or we'll see how it goes. But what we have seen is, and I'm showing you data from Jan 2023 itself till about first quarter of this year, you can see that roles, and this is data from LinkedIn research, that roles in AI, ML, and data science, background have increased by 4.5x in the duration of the last 2 years, right? So, and for that shorter duration, it's a massive increase. Apart from AI, ML, and data science roles, there is also almost like a 2.5x growth that data engineering role has seen. So job openings, I'm talking about job openings that you see on LinkedIn, that in the AI, ML field has grown by 4.7 and data engineering has grown by 2.5x. Now, what does that? Now we are going to get deeper into the fact that why AI, why do you need to learn AI in a more structured and comprehensive way, right? Let's talk about the impact on salaries. The impact on the salary, the gap that you see by being, say, a traditional. So I'll take us through for the next few slides. I'll take the example of software engineering. So a traditional software engineer versus an AI software engineer, what is the gap in salaries that they observe? The gap can be seen from, say, an SD1 level itself to about level 7, right? And the impact gets more and more pronounced. So if you can see on your screen, at L6 level itself, you have a gap of about 10 lakh per annum. And at about L7, you have 35 lakh per annum gap, right? So if you are an AI-enabled engineer, your potential to earn not just 50 LPA, but your potential to earn about 80, 90 LPA is more pronounced, right? And this is still data, say, starting or mid of this year, and this is only, compounding. Again, in the interest of, diving deeper, the other thing that I want to present is when roles are opening up for certain domains, what is the requirement for AI ML skills? Is it even being mentioned, or is it all hearsay, right? If you can see, and I'll show it to you in flesh also, I'll take you through certain job descriptions where you can see how AI is being asked for in job descriptions. So as you can already see, for data engineers, there's already a 50+% requirement of AI ML skills in the job roles. Software engineers is not far behind. It's about 37%. This again, I think by this time of the year, it would have grown to about 40-45%. Engineering manager also has the AI ML skills mentioned in the job descriptions of open roles, up to about 27%. Whereas, an engineering manager who's a pretty senior person in the ladder may feel that they do not need to upskill, but to scale the enterprise with AI systems, to lead a team of AI engineers, you need those skills. So it is important for ICs, for managers, for leaders all across the board, right? Now, I was talking about showing it to you in flesh, right? So I've taken again an example of a couple of software engineering job descriptions from LinkedIn. So one is of LinkedIn itself, staff software engineer role, and one is of Microsoft software engineer role, right? Both of these, and this is just a sample, right? And you can go yourself and check. And I'm sure a lot of you are already in the market trying to switch or find another job. You'll find these mentions of building autonomous AI agents, building AI systems at scale, developing multimodal AI applications, deploying them and scaling them in cloud environments. All of this like a regular feature now. So I think about last year starting, it would be sparsely mentioned, but now it's not. It's an essential need. It's something that every company is looking forward to, because everybody is realizing the compounding effect and positive effect that AI has on an enterprise level. So now that brings us, while we have established the need to upskill oneself or up-level oneself with AI skills, sometimes it's not easy to get started. Okay, you may be stuck in something that is unstructured, or you do not have right now you don't have a structured path that you can follow, so that you get the discipline to get to it, give it a few months, get that skill, crack a good interview, and grow in that ladder. So sometimes all of these are very, very, very general, very it's mentioned across by all of our learners that these are the challenges they were facing. But when they picked a path with us, they did see the fruits that they were expecting. So I'll explain the path to you. Now, in the last 2 years, we have been talking about the growth of AI in the work environment in the last 2 years. What we understood was, while we are preparing you to crack the interviews for top tech companies, what is essential is to also help you up level in the right skills, plus help you crack interviews, right? So it is something that it's a 50-50% game. You need to upskill to crack good interviews, right? And we also understood that one size cannot fit all. So somebody who's from a 8+ years of software engineering background versus again an engineering manager with say 18+ years of work ex, there's a lot of difference in the expectation, in the way they already look at technology, and hence the way they learn and upskill and uplevel themselves also has to be different. So we started with who you are. Okay, so you could fall into any of these three buckets that is there in front of your screen. You could be an IC or a mid manager with 0 to 15 years of work ex. You could be a 15+ years of work ex tech professional who's a specialist, who's a principal engineer, and still an IC. Or you could be a leader, a manager, or a director, or a VP of engineering with 15+ years of work ex. So we try to bucket all of you guys in these three buckets. And then we try to understand what are your goals. When we spoke to hundreds and thousands of technical professionals, what we found was the goals typically fall into two buckets, which is either in your current domain. So for example, if you're a software engineer, in your current domain, you want to add a thick layer of AI skills on it. You want a domain, you want depth in your domain, so that tomorrow, if there are AI projects up for grabs at your company, you're able to get those, right? And raise your hand and take that step and take it to scale. The second is engineers or tech professionals who want to switch into machine learning completely. So either they want to become ML engineers, or ML based engineers, or even leaders who just want to get ML skills so that they can lead a engineering team of ML engineers, right? So we have two offerings for you. The number one being flagship machine learning program, which is for people, like I said, who want to become ML engineers or become ML pros, basically. And the other is transformative Gen AI for different tech professionals. And when I say different, I'll tell you how that different looks. So hang on for the next few slides. Let's talk about the flagship machine learning program first. It's a 6 + 4 months program, 6 months of up leveling in machine learning, and 4 months of prepping for interviews, so that any real world interview is a cakewalk for you, right? So we have been doing the interview preparation for over a decade, not just in India, but also in the US, have a global view on it, global experience of it. And ML part, the learning part will last about 6 months. So you start with the learning part. So you have in the month one Python basics. A lot of our technical professionals, they tend to refresh their understanding of Python, because that's the starting point for everything. You go from month 2 to 6. You go from classical ML to deep learning, to also then doing projects in generative AI, agentic AI, right? So you'll go from supervised, unsupervised learning to building deep learning architectures, using neural networks, and then get into building apps using ML and agentic AI both, right? We also, in those 6 months, give you a choice to specialize into 4 specializations, which are at the bottom of your screen. So there's advanced NLP, there is advanced computer vision, ML ops, and big data with Apache Spark. Okay. Once you're done with this, you also have the option to prepare yourself in depth for the interviews that you want to give. And our level of preparing you and upskilling you is so that you can tomorrow crack even a MANG interview. So MANG interview, any interview with Meta, Amazon, Googles of the world, right? So that's the kind of quality we promise to provide you. And the preparation that we provide you are all based on your profile. So for example, if you are a software engineer trying to become an ML engineer, your mock interviews, your behavioral round, all of that will be customized for the role that you're preparing for. So those are the roles that you can see in front of you: DS, MLE, DA, BA. And in the interview preparation, in depth, we cover how to crack behavioral rounds, how to negotiate on salary, how should your resume look so that you can stand out, how to optimize your LinkedIn profile, all of these. So and mock interviews are generally with people like Suhrid, right? So people who are already building AI systems at scale, who already have about most of, like in the previous slide you would have seen, most of our mentors are all of our mentors are actually practitioners currently in the industry, and they have on an average 13 plus years of work ex. Now, the approach that we take to learning and why we are so confident of what I'm presenting to you today is, at every milestone, you will be applying whatever you're learning. And these are not toy projects. I know a lot of people say that you will apply, you'll do projects, but these are production grade projects that you'll be working on. Okay, so and at different milestones. So whenever you finish a couple of modules, you'll deploy it into into something working production grade, so that you see it in flesh. All of this will help you build a portfolio that you can then present in interviews. Okay, so our learning and teaching approach is very, very build specific, like build yourself specific, and I think that actually is what is needed for mid senior professionals, right? If so, for example, even if you are starting or you are at an advanced stage, you want to build with things, and that's what I think the core of an engineer is. The second product that we have is for, like I said, somebody who wants to add that thick layer of AI skills in the current domain that they are in. And I'll take you through the domains in just a jiffy. The program is called Transformative Gen AI for Tech Professionals. Now, I'm sorry. Yeah, this is a 14 weeks program of just up leveling. So you go from, again, you start with Python basics for the first 2 weeks, and then go into learning the latest in AI, right? So building foundational AI agents, building advanced AI agents, and then whatever you have learned, again, giving it shape and form and building a portfolio with domain specific projects. So for example, if you're a software engineer versus a technical program manager, you have different projects to go through. Okay, so either you choose from up to a list of 10 projects that we have, or you can bring your own project and we'll help you solve that, right? So it's very customizable. It's very also learner centric in that way. After the 14 weeks, for 12 to 16 weeks, you have something called, again, the interview preparation module starting, right? So we teach you the basics of interview, like something that is asked in every interview. You start with the essay, then you go into system design, and then all the career skills teaching starts. For example, how to build a resume, like I mentioned, how to optimize your LinkedIn, You sit in up to 15 mock interviews with experts like Surhit to be able to understand, to simulate an environment for you where you exactly know what is going to be asked to me and what is what is expected out of me. And by the time you actually get into real interviews, believe me, it will be a cakewalk. These were the customization, no one size fits all of that is this is the reason to believe all of what I was saying, because whatever we are offering specifically for transformative Gen AI program, it's customizable for these 18 tracks that you can see. The SWE track in itself is split into four: backend, full stack, front end, and test engineer. And then the list goes on to tech product managers, technical program managers, engineering managers, data engineers, DevOps. All of these profiles are covered. So customizable projects, customizable interview prep, and hence you get the best value out of it. So you're not just treated the same across the board in a class of, say, whatever number of batch it is, but we understand what you require, right? And don't worry if you're just getting started or you're already at an advanced stage, the course will be valuable at any stage of your upskilling. The point is to get started. In a nutshell, whatever I've explained is two offerings. Want to become an ML pro? Go for a flagship ML program. Want to put a thick layer of AI skills on in your current job role itself and prepare for tech interviews? You have transformative Gen AI available. Flagship ML program is for 6 + 4 months. Transformative Gen AI program is for 4 + 3 months. And both have live classes. You will get unlimited technical coaching sessions available. You will have up to 15 mock interviews with our FAANG Plus experts, and both of them have career services available. Now, on to my last slide about how much these programs cost. The flagship machine learning program is for 3 lakhs, and the transformative Gen AI program it starts from 1.5 and goes up to 2.8 lakhs, depending upon your domain, depending upon your role. So if you want more information, you can talk to your program advisor, or you can just drop in your email in the chat right now, and I can fast track your conversation with the program advisor. Don't worry, we have profile-based scholarships to help you out. We also have flexible financing available where you can pay the fees post scholarship in 3, 6, 12, and 24 months period. Okay. We have special alum discounts. We also have a facility where you can enroll right now, because we have limited batches. You can enroll right now and you can start anytime. So we typically sometimes have engineers who are busy, maybe say in the month of November or December or January, and they want to start like 3 months down the line or 1 month down the line or something. So they block their seat and they can start anytime. We also provide placement assistance. And the fact that I'm confidently standing here and taking you through this slide is can be seen in the last point, which is 50% refund. So after successfully going through the program as it is set by our curriculum team and delivery team, if you are not able to find a job, we also give you 50% refund. So I know lots to take in the last 10-15 minutes that I've taken. But if you have any questions, I'm still here. Post them in the chat, or our program advisor will get in touch with you and have a deep conversation with them. Uh, they'll understand your profile, they'll understand your needs, and try to solve every doubt that you have. So again, Surit, back to you. Take it off, and you can continue the engaging session that you were having. Thanks.
Thank you. Let me get back to right here. Okay. Right. So next, I want to talk about a little bit going into, before we go into the demo, just again give a high level abstraction of what are the different pieces that we'll be assembling in the demo. So there are three main LangChain abstractions associated with RAG that will be that make all of this end-to-end processing of RAG pipeline fairly simple. One is the LLM, and we have many interfaces and APIs available to us for the LLM. We have the vector store, which is, as I mentioned, Pinecone, Chroma, Qdrant, FAISS, all of these different vector DBs are available to us as retrievers. And then you can also embed memory management into our RAG-based systems. So in as little as like all of these, there's a hundreds of lines of data pre-processing, data modeling code that will come before this. And then there's like another 100 lines of data post-processing and productionizing it and all of that will come after this. But what I really wanted to say is that the core part of ML or the core part of LLM, which enables you to assemble all of these pieces together, is usually a small part of code. A large part of code is orchestrating all of the scaffolding around it. So another thing that vector DBs and all of these abstractions like and packages based off of vector DBs that they enable you to do is they enable you to handle these spelling mistakes also very well, because they do this semantic search, which look at not just the words and the characters within the words, because they look at the context and the meaning associated with the word. If you spell king as kings and ask a question, how similar is kings and man, and then queen and women, it would still give you a reasonable answer. Um, it doesn't worry about capitalizations and case differences, and and the memory aspect of it also enables you to maintain a certain level of continuity in the conversation. For example, if you're talking to the RAG-based system about one particular person, and then you refer to that person again with a pronoun, the system, if you have enough memory initialized, it should be able to go back and remember who you're talking about. And a lot of these systems also have abstractions for designing end-to-end pipelines based on YAML files, if you guys have worked with YAML files. But while these configuration files are very powerful, many developers prefer just pure code for flexibility and familiarity. So, right, we'll cover this set of we'll cover some debugging and optimizing aspects, and then I'll walk you through the notebook. So sometimes your RAG-based systems can fail to find the right information, and we need some diagnostic method to calculate to see what is going wrong. So LangChain allows us to enable callbacks. What callbacks means is that the moment our input is passed to the LLM, LangChain is able to set a trace. Trace meaning everything that happens behind the scenes. You can bubble that up all the way as an output, so that you can inspect the output and see exactly where the chain deviated from expected response. What if you had changed the prompt ever so slightly, what could the response look like differently? And you can do all of these experiments with these callbacks. um, as I mentioned, it lets you examine the output and the retrieved chunks. So when you passed your input into the LLM and it went to the vector DB, which were the elements that were identified as the most closest document from the vector DB? So does the problem lie in initialization of the LLM? Should you be using a more powerful LLM, or should you just be using a better vector DB? Should you be using a different chunking strategy as opposed to just throwing a more powerful LLM at the problem? All of these questions can be answered based off of these callbacks and context retrieval visualization provided to you by LangChain. Some of the common problems with RAG-based systems are it gives you the context, but it gives you the wrong context. For example, let's say you have a set of documents and you have broken down those documents into different chunks in a manner such that whatever is retrieved from that vector database points to the wrong information associated with the question. So for example, in our insurance LM company, if we wanted to ask a question about IoT Innovator Award, um, it's if you don't retrieve the correct document, maybe the response could be I don't know. And so how would you tackle this problem? This clearly is a problem associated with your chunking strategy, right? Like we have the documents, we have the LLM, it should have found out this particular answer. So why did it not do that? One reason could be that you broke down the documents into very, very like small chunks such that it wasn't able to collect all the context associated with this IoT award. And one thing to do therefore could be maybe increase the chunk count. So essentially, instead of giving only like the top 3 or 4 chunks to the model, maybe give more context to the model. Maybe adjust the chunking size and the overlap. That what I was talking about is there are some documents which are very well structured and you can use only a part of the document as the chunk. There are some others which are not well structured and you may have to use some chunk overlap to get a good performance. Finally, you can just, at the expense of memory storage, you can use the entire document and create a summary associated with the entire document and append that entire summary chunk uh, to your internal chunks of that same document. That is known as contextual retrieval. The price that you pay there is you expend a lot more compute on memory and storage and memory processing. The gain that you get is hopefully better retrieval. And so increasing the chunks again, you can because your input prompt has more context now, you are able to identify more accurate information that may be hidden in the it's like identifying a needle in the haystack, but you are providing it the exact location and the position and the context around that needle. So finding that needle becomes easier. And this is as I mentioned, there's always a price that you pay when you are creating a system with larger context with more chunks being thrown at the LLM. The benefit is that your LLM has better information coverage and therefore has a tendency to answer questions correctly more often and give more comprehensive answers. But then, as you can imagine, because you're throwing more and more context and more text at the LLM, it has to process each of those chunks and the documents that you have given as an input. And so that increases your latency. So that your same LLM and your same RAG pipeline takes a longer amount of time to process that. It is possible if you have provided it too much information, that is known as LLMs are known to have a recency bias. What recency bias means is that in a long prompt, it's going to focus on the beginning of the prompt and the end of the prompt. So it loses the information in the middle. That can lead to possible distractions if your prompt is too long and there's irrelevant pieces of information associated with the question. And of course, because you're giving it more and more tokens, it has higher token costs. And so, like many things in data-driven modeling and computational modeling, even RAG-based pipelines are there's an iterative aspect to it. You have to see what chunking strategy works for you. You have to see what retrieval strategy works for you. And you have to enable like a CI/CD, continuous integration, continuous development type of a pipeline to have this feedback loop going on which hyperparameters work the best. I think I'm gonna skip this one because, right. Or I guess I just covered this and there are techniques where you can enhance your RAG-based system, like where we just did this vector embedding search. There are like hybrid searches which focuses on not just the vector embedding but other algorithms like TF-IDF, which is this frequency based search and keyword based search. There's ranking models that based off of the documents that are retrieved, how can you improve the ranking associated with them to mark which of them are the most relevant. Query expansion is something where you can generate variants of uh, your query to see what if different documents are retrieved based on slight deviations from your original query. So there are some techniques to enhance your RAG-based system, but again, the previous a better way to do it is just like by tuning these hyperparameters and monitoring what the performance of the rack system is based on your validation data set. So with that being said, let's go to the demo. Here's the link from which the demo is based off of. And so what I'm doing here is nothing but, hopefully you guys can see my screen, okay? What I'm doing here is nothing but, we are just going to design a question answering agent that is an expert in this insure tech company called Insure LLM. And the agent should produce responses associated with the products of the company, the people in the company, the contracts that the companies have, and so on. So again, what I'm doing here is nothing but just installing some basic packages. Um, Importing some basic LangChain frameworks, some native Python packages, some scikit-learn packages for visualization and plotting. We are using OpenAI's GPT-4o Mini as our LLM. As I mentioned, a RAG-based system has a few components, right? LLM is one, Vector DB is another one, and so the LLM that we are going to use is GPT-4o Mini. You could have used anything, which is like Claude, Llama, or any one of those. Because you are using a closed source LLM, we will need an open API or OpenAI API key. And so I have initialized my key at the top. Your key should be, um, you, OpenAI will charge you based on the number of queries. If you exceed their free tier, then you're expected to get the paid version of their models. So make sure if you initialize your OpenAI key, it's not public, it's a private key. And then what I've done is now that I have my LLM and the OpenAI key set, all that I'm doing here is I'm creating a knowledge base folder. So what does this knowledge base folder look like? A knowledge base folder looks like so, which essentially has information about the company, information about the different careers associated, like what type of roles are available in the company, um, who are the different employees in the company, and some information associated with those employees, like their personal information, their salary, their career progression, some feedback, and so on. And we also have information about the different products and the different contracts that our company has. So all of this information is stored in our proprietary documents associated with our company. So what we have done here is we have just taken all of those documents, and we have split them. We have split them into different chunks, with each chunk being like 1000 words, and there's an overlap between chunk number one and chunk number two of 200. So what happens is chunk number one is the first 1000 words, chunk number two is word number 800 to word number 1800, chunk number three is word number 1600 to 2600, and so on. So you're essentially just creating a minor overlap, and these are hyperparameters, right? You would evaluate the model based off of these hyperparameters to see how it's doing. And so we created some chunks. All that we have done so far is break up our document into multiple different pieces, and all of these methods are given to us by LangChain or LangGraph type of frameworks. LangGraph, there was a question. LangGraph is just another framework based on top of LangChain. Slightly more complex use cases use LangGraph. LangChain is useful for like sequential processes. Right. So as I mentioned, the next thing for us to do is take these chunks and convert them into vectors, right? So we have text documents which we have broken up into small pieces of text. Now, the next thing that we need to do is take those small pieces of text that we have developed or broken our large documents down into and convert them into vector embeddings. Why do we want to convert them into vector embeddings? So that we can make questions like, what is the word that is most similar to women? If I make a claim that king is similar to man, so then the answer should be queen, right? So we can make statements like that, and so we want to convert these pieces of text into a set of numbers, specifically a set of vectors, which are known as embeddings. So we already have embedding models. We are going to there's embedding models like BERT, Distill BERT, and Word2Vec is another one before the Transformers era. But what I'm trying to say is that we can use any one of those models and create a embedding associated with our chunks. And see, this is where our vector store comes in. It's relatively a simple line of code that initializes your vector database with the name that you provided and takes your embeddings and also this is deleting the thing if it exists. So this is creating the vector store. So it creates the vector store and creates the embeddings and initializes your vector store with the documents that you provided it with. And so now that we have this, you have all of your 413 documents have been converted to 413 vectors with a certain dimensionality to them. Where does this number 1536 come from? That is just a number that OpenAI decided for their embedding model. Different embedding models will have different dimensional size, and there's advantages and disadvantages to that. So once we have our vectors and a vector DB initialized, the next thing that we can do is create our documents for visualization. So all that is happening here is we get our documents and the embeddings associated with the documents. So we are looking at the documents, the metadata associated with the documents, the vector representation associated with those documents, and then now we're just prepping the data up for visualization. There was some comment in the chat that you can use UMAP for visualization. Absolutely correct. UMAP, TSNE. Honestly, you could do k-means clustering if that's what you initially want to do and are most familiar with. But the point that I'm trying to make here is that once you have your documents which are stored in your vector database, your documents have, each document has a vector associated with it. And now you can visualize these documents on a two-dimensional or a three-dimensional graph, because us humans, we can visualize information in two-dimensional or three-dimensional. Beyond three-dimensional, the visualization or the intuition behind it starts starts becoming difficult to imagine, right? So here we are using a two-dimensional technique to visualize our documents. And so as you can see, what is happening here is maybe here. So what is happening here is that all of our 403 different documents are plotted on this graph, and all the red, or let's look at all the green dots. So all of these green dots are similar to each other. Why are they similar? You can probably tell, right? Like this is all the information about employees. So this is about um, so all of this is some information about the employees. So Robert, Chen, Alex, Jordan, these are all the names of the employees. There are some things which the LLM is getting confused about. For example, this green dot is associated with the employees, um, but there are some other like maybe some company documents has information like data engineer, machine learning engineer, software engineer, and some company specific roles like the job description also has information like data engineer, DevOps engineer, customer success, account executive. And you can see where the LLM is getting slightly confused, which is why these yellow dots and these green dots are close to each other. But that's the that's the point, that we have to tweak some of these models a little bit to elicit better performance. But at least you are able to take all of your documents and store them in a vector DB such that, broadly speaking, your clusters represent similar kinds of information. So this was a two-dimensional graph. That exact same information here is plotted in three-dimensional settings. So in a three-dimensional setting, you can better see the separation between the yellow and some of the other things. So like there's the company specific documents which are yellow, there's employee specific things which are green, there's a contractual information. These are the contracts that the insure LLM company has with all the external companies. And then the blue ones are all the products. So products, also the different types of products that's available to the companies. Now, once we have all of these things initialized, we are ready to initialize our LLM and the LangChain pipeline. So we have our LLM, we have our vector DB. We are going to use our GPT-4o model. That's the LLM that is initialized. We have our memory that we have set. And then we can ask our LLM with and actually this is we have the vector DB, we have the memory, and we have the LLM. And this is our entire chain. So we have we have initialized our RAG-based pipeline with all the three main components that we were talking about. And with that being set, we can ask our LLM some proprietary question that you cannot ask ChatGPT, because ChatGPT doesn't have access to this, right? We can ask, tell me about Insure LLM, and our LLM, our RAG-based system comes back with a response, which is Insure LLM is an innovative company founded in 2015. It offers a range of products for insurance products for auto, home, life, health, and so on. And as you can see, that is true information, right? Maybe I can go to some of those docs here. So if you look at some of the company docs here, that is what you would see in this doc. It's a company founded in 2015. It has a range of different products for so see, it has a range of different products for life insurance, auto insurance, home insurance, and so on. And that is what our RAG-based system answered the question like that. And as I was mentioning, you can also see what kind of context was retrieved when you ask this particular question. So if you ask who is the founder of Ensure LLM, you can see that the founder of Ensure LLM is Avery Lancaster. That was the information that was stored in our documents. And you can see what exactly happened in behind the scenes when you ask this question. So you asked a question and this was the prompt that was passed. These were the documents that were retrieved from our vector DB. Ensure LLM was founded by Avery Lancaster. That's a very relevant document. So that was the one that was retrieved. There was some overview of Ensure LLM that was also retrieved. And then based off of all of this information, our LLM gave us a final answer associated with this. So that's really all that I wanted to convey. And then typically when you develop a POC, what you can very easily do is set up like a UI or a front end to what is in, to showcase your project. And so this essentially does the same thing but puts a pretty UI on top to just see how your RAG-based system would function. What is the capital of See, so it says, what is the capital of India? I don't know. And this is what the answer that we want, right? Because our system should not answer questions around stuff that is not in our documents. This is what I mean that it prevents hallucinations. It's only supposed to answer questions around the RAG-based system. So we can do something like, who is this Avery Lancaster guy? Hopefully it says he's the founder or CEO or something. Yeah, see, he is a co-founder and CEO of Insure LM. And all of this is based on, or she's the founder. All of this is based on the information that we provided to our system in our vector store documents and so on. So that's really the a very high level demo about RAG-based systems. You have multiple different parameters. Like we went through a lot of content actually right now that we typically cover here in like a 5-hour session over multiple weeks. But hopefully I gave some intuition on what LLMs are, how a RAG-based system can be embedded into the LLM, and how with relatively small amount of code, you can get something that is pretty powerful. A lot of the work that happens from this point onwards is something that is similar to traditional software engineering, which is taking all of these pipelines and then creating a automated framework, evaluating them, deploying them, setting up infra for model monitoring. And there are tools which are coming up to do exactly that. So LangFuse is one such tool, which is used, their entire value prop is evaluation of LLMs and evaluation of Lang RAG-based systems. LangSmith is it's not for evaluation, but mainly for observability. So it gives you a graphical user interface on trying to see how your LLM or a RAG-based system is operating on the back end. And so there is a lot of different things that we glossed over in the last 20 minutes. But the point is that in our curriculum, we typically go through all of these things very systematically and give you enough tools and techniques such that you can go ahead and learn and explore these techniques very confidently on your own and are well prepared with some of the latest and greatest tools which are used in the industry. So let me see if there is anything more on this slides. Right, so that's pretty much all I had for now. Rohan, do you want to take back control?
Hey, sorry. I was just like, I realized I was on mute. So here what I've done is I have taken the questions and made a small sheet. I put it in a GPT or whatever has been put over here. So there are like few questions. How I've like categorized it, we may not be able to take all. Can I share my screen once if it's okay?
Yeah, of course.
Just give me a sec. Yeah, I think what I've done is I've categorized some questions which have been asked over. So there some are very basic, some are a bit advanced. For example, the first question somebody has asked is, how do you customize the chunking process?
Right. So in order to customize a chunking process, typically what is done is you set up your observability infrastructure, which is, let's say, LangSmith or LangFuse. These are again packages that you use on top of LangChain or a LangGraph. And now how you would do a unit testing in a traditional software environment where you are going to test your function with a variety of inputs, observe what its output is. You would do the same thing here. You would essentially say, okay, let me see what if I use 1,000 chunks per document, what is the resultant performance of my system? And how do you evaluate the system? You essentially have a set of questions that you manually annotate, ask those questions to the RAG-based system. The RAG-based system comes back with the answers, and you calculate some metrics like how many of them were correct, how many of them were somewhat correct, how many words within your answer and the LLM's answer correctly matched, and so on. And based off of that, you would tune your hyperparameters associated with the chunking process that works well with your system.
By the way, just a question. I think I saw a lot of text. We had shared the repository link, right, with the folks, the notebook link and all. Just asking on the chat.
I did share the
Yeah.
link, yeah.
Cool. Because somebody asked me, can you share the code, please? Coming to the next one, I'm not saying we pick everyone. I'm just picking at random. Like, if you have to pick one from RAG use case and integration, there are certain like very specific use cases. For example, is the framework the same for video and audio also like text? Is it the same? This is from Shruti.
Yeah, so as I mentioned, a lot of the times, a lot of the code and the work in machine learning and computational modeling, data science space goes into data prep and input preparation. The core model is agnostic to what input it sees because at the end of the day, it just takes a series of numbers as inputs. In this particular case, those vector embeddings, and so there are packages to convert audio into embeddings, images into embeddings, text into embeddings. So yes, the framework remains the same.
Got it. There's one more from Riaz. Again, it's a use case specific. Just picked it up. Riaz, we're answering a question live. What would be the criteria for choosing a specific tech stack for RAG apart from the foundation models in VectorDB? You used, I think, LangChain in your current example. So it's a bit
Right,
use case specific question, but if you would want to address that.
right. So it is very heavily dependent on the context of your company. For example, at TikTok, they have their own AWS-like system called ByteCloud because ByteDance is the parent of TikTok, and they have ByteCloud, which is the same thing as AWS but designed by ByteDance. And so you have interfaces where you can host LangChain based models in ByteCloud. They have their own LLMs as well, and these are just tools to achieve a particular task. What I typically encourage folks to do is not get married to a particular tool because tools keep on changing. But what just make yourself aware of the foundation knowledge and the core techniques that are deployed in using and building these tools. So yes, you are absolutely correct that you can use LangChain, you can use AWS hosted services and mimic a RAG-based application using AWS Bedrock, AWS Glue, SageMaker type of things. You can absolutely do so. But at the end of the day, what I showed you here, you would be mimicking some similar concepts in AWS or GCP or Azure to do that. And a lot of the times, which tool to use is surrounded by what the remaining code base in your company looks like. If like all the remaining folks in your company have built something around AWS, it would be easiest for you to integrate your RAG-based system into the AWS framework.
Got it. Riaz, hope we addressed your question. I think there's one question from Rajesh. Rajesh, please repost your question. I'm not able to find it. I accidentally logged out within the session. My laptop battery died. So if you could just repost your question, be happy to pick it up. Picking one on the testing and privacy. I think when we pass RAG data to LLM, how does privacy remain intact or privacy remain intact? I usually fumble with the right pronunciation.
Right. So for a RAG-based system, you should know that if you are using a closed source LLM, like ChatGPT or GPT-4 or something, the moment you are querying something to GPT, your data is exposed. So that is something that you should keep in mind. But on the other hand, GPT-4o does have paid API services. For example, if you get their more expensive API, it gives you permissions on those APIs where you are able to set what data to record, what data to not record. In your vector database that your RAG is querying from, in your vector database itself, you can create controls where the information that is retrieved is very specific, and you design which information should be marked as sensitive versus not. So those are some of the techniques that you can use um, to deal with privacy and ensure that privacy is respected.
Got it. There is one, I think just one call out. Just give me one sec. Girish, if I'm not wrong. Girish, can you please repost your question? I think, like I said, I accidentally logged out of the session for a minute, and the Q&A history for me is completely gone. Just four more questions, folks. One is, I think, this is continuation to the first question you addressed, how to customize chunking process. There's a question which is asked around what would be the not this one, sorry, my bad. Will chunking play a major role? We have key value content documents rather than descriptive form. I don't know. I think this is in continuation to the first question, but if you could decipher what the question is, could you address that?
Yeah, so I think chunking does play a fairly major role in a RAG-based system. For example, if you have a fairly um, if you have chunks that are very, very broad, you are missing out on nuanced information within smaller paragraphs in a text, let's say, because even the chunking model themselves, at the end of the day, if you're going to create a vector embedding that is storing the information for 1,000 words or 10,000 words, it's going to try to focus on what is the overall gist and the most important aspect amongst these 10,000 words. And so there's a happy medium that you have to play around with on asking the question on which chunk size is suitable for your particular task.
Got it.
So it's an iterative exercise, but yes, chunking strategy is it does play a role in retrieval accuracy and precision and recall metrics.
I think there's one real world question is around can we build robust RAG based agents or RAG based agents by using company database because data is stored in SQL database from Girish.
Yeah, you can use RAG-based agents using SQL-based databases. There are connectors and data loaders available to you from LangChain which connect to SQL DB. So yeah, I mean, you can replicate the same pipeline. Essentially, what you would still have to do is you would still have to create this vector embedding type of a search where you query the documents from your SQL database and match your input prompt with the documents that you have retrieved from the SQL database. So you can do that, but you will still have to do it. You'll still have to have this step of converting your documents in your SQL database into a vector embedding for semantic search.
Just two more. While we are doing that, let me just launch one very last poll, folks. I've just put it out. I think I was just going through the poll answers and everything that you've written over there. There is another masterclass which is being held on 20th of April. which would be on how do you build a smarter AI search. I really hope that I had that landing page and everything ready. It's still being made, but this is just early access. If you are interested, it will be happening at 7 p.m. IST on 23rd of November. Sorry, 20th of November. It would be it would be taken up by Shashank, who is a BITS Pilani undergrad, and currently he is working at Microsoft, and he would be taking you through how do you build smarter search systems using AI. If you're interested, it will be another session of 1.5 hours. Do feel free to tune in. We are making it a little bit more basic. I think a lot of you had mentioned that you are starting your journey with LLMs. So I think it's a bit more basic session compared to this one, if it was a bit advanced for you folks. So do respond to yes, and we'll be happy to send the registration link your way. Suraj, just one last question before we go. Uh, just again, I'm just randomly picking. Let me see if there's a better question in the Q&A. Folks will share this Q&A document you're asking. I'll share it. Happy to. Just one second. Let me share the links to you. I'm not sure if how relevant this is. This is the GPT version. I'll post it in the chat. Yeah, this let pick one. I think even I'm curious about it. Is LangChain similar to NA10? If not, what is the difference? How do you differentiate between the two pieces?
Yeah. So N8N is something which is what I what they call no code framework. It's called no code or low code framework because you have these drag and drop elements. You can drag and drop icons into your web interface and build a RAG pipeline using these drag and drop elements. LangChain, LangGraph, Crew AI are verbose code frameworks. You have to like code up all of those drag and drop objects that you are um, that encompass the structure of your rack based system. So they do same things, but LangChain gives you more modular control. If your use case is extremely niche, you should use LangChain. If your rack based system is like an email comes in at every 8 a.m. in the morning and you want to summarize the email and store that email and then have a chatbot based on the summary associated with that email every 8 a.m. That's what N8N is probably very good at.
Cool. I think thank you so much, Surat, for this, and thank you so much, Niyati, for being here. Folks, if it was a bit tough for you, hence these polls help us keep curating some things. Uh, what we'll do is we are hosting another session to try to tune in. This will be a bit more basic level than this one. But thank you so much, Surat, for taking this up so early your time. Really appreciate you taking
Always.
this up. Folks, if you're interested, like I mentioned, if you're interested to know more about our offerings and all, feel free to reach out to us. There are a lot of interview Kickstart specific questions as well. Niyati, if you would, are you there right now?
Yes, hey Rohan.
Can we take 2, 3 questions if it's okay
Sure,
on the
sure.
interview
Yeah.
Kickstart piece? Surat, if you want to drop off, feel free to. There, I just want to keep
Perfect.
one section for Niyati as well. Thank you so much. And again, we're going to do one more session with you, by the way, very soon. But thank you so much for taking this up.
Okay, thanks.
Uh, Yeah, Niyati, I think there's some career transition related question that people have asked.
Yep.
Just give me, I'm not saying we'll pick all, but let's try to pick 2, 3 so that they don't get under addressed. Uh, so one is, sorry, again, this is like most related. Yeah, just one sec. So there was one question around, as a mobile app developer, how will I find a place in AI/ML companies as expecting 4 to 6 years in AI/ML experience? So, for example, the core question over here is somebody who doesn't have like a on the job experience. How can they navigate through their career? I think upskilling is one way for them to do this. Like they get upskilled, they showcase through projects and all those things, some experiential
Yeah.
learning. But if you could just throw some light on it.
Correct. Like that's a great start, Rohan, because anybody, so the programs are generally meant for beginners also. So if you have not had, not everyone, AIML has just started taking center stage, right? So not everyone has had the opportunity to actually dabble on the job in AI projects. So whatever projects we do in our programs generally help you build a portfolio as well as skills. So whatever you're learning, that's getting cemented. You're building a project with it, and you can showcase that in interviews or even in your promotion conversations.
Got it.
So even for beginners, it's a great place to start.
Got it. Thanks. One is, I think, which I was seeing very often being asked in the chat also, are our courses relevant for non-tech folks with 3 years of experience as an MI executive? I
See,
do understand we have pro code, no code offerings, but somebody who is from a non-tech background, I don't think we are relevant for them, or are we?
See, currently, most of our programs are not typically or highly relevant for non-tech folks.
Got it.
We do have plans to launch something for non-tech folks, but if you have understanding of Python, specifically, still go ahead, have a detailed conversation with the program advisor so that they can also, tell you, they can understand your profile a little more. At this point in time, due to the constraint of time, we can't discuss it on call, but have a talk with them, discuss in detail, and they will also guide you. But it's more pro code based as of now.
Got it. I think Anil, Nidhi, let's take this one. Please correct me if I misspoke on some piece. The question is around they have 20 years of experience and are now taking trainings on Gen AI from various institutes, which is great. I think today would be a part of your training journey as well. They want to transition as an AI program manager. While they have asked how IK can help, they have a lot of certifications. Two parts, Anil. One is we specifically cater a lot of the folks who register to us are mid to senior folks. They are professionals with 15 plus years of experience because for them, the current AI wave, the current changes in expectation in different firms is something that they are finding hard to navigate. And another piece is they like technical program manager was somebody who is a coder and starting his or her career in the early ages. There's an expectation, not an as hardcore an expectation of coding. We have courses which are fairly no code courses, which specifically focus on management folks, which help them transition to AI PMs as well. And not just that, they help them upskill themselves in the current role with regards to Gen AI so they can use those things in their existing roles as well. So we have specific courses around AI PMs and TPMs and EMs. Niyati, would you want to add one specific line on this?
Yeah, another thing I would like to change to my previous answer was that there is pro code available, of course, that's the ML program, but also low code, which is our generative AI program. So,
So
for example, and Anil, I think you have done a lot of hard work already. I mean, kudos to you, firstly, to have that rigor to do so many certifications. It's amazing. We specialize in dealing with senior professionals like you and giving you the right customized pathway, just like Rohan mentioned.
cool. I think let me see if there are any questions on Q&A side. Otherwise, we can wrap it up.
Sure.
Folks, recording, like I said, will be maybe shared in some time, not immediately available. Docs and all, I think repositories have already been shared by Suraj on the session, during the session itself. Is there any other question? Another DevOps engineer with no coding experience, how exactly can this course help in my career? Again, similar sort of questions. You want career specific questions, you need counseling. Program advisors would be happy to assist you. If they can't address your queries, they'll be happy to loop in somebody from the curriculum team or somebody from the specific team so that at least you can make an informed decision. Like somebody had mentioned, it's a significant investment. There are discounts and everything available. But we also want to make sure that whosoever enrolls into our courses are relevant for them as well. We don't do that misfit sort of an approach like somebody gets that course and they don't find that value out of it because otherwise we'll have to pay them the refund, by the way. So we are also very careful in the screening process. Hence, I'm saying at least speak to a program advisors. They'll be happily telling you whether your profile is relevant and at least relevant from our course perspective, whether we can serve your career goals or not. Thank you so much, folks. Thank you so much for tuning in. Thank you so much, Niyati, for taking this up. Folks, have a great night ahead of you. It's already 9:30. But thank you so much for tuning in. Have a good night and have a good day. Bye-bye.
Thank you, guys. Bye.